Good morning, Toronto. Today, news, we are going to learn about natural gas. Discovery, recovery, transportation, storage, and distribution of natural gas. What is natural gas?
Natural gas is a naturally occurring hydrocarbon. Hydrocarbons are known to be an organic compound consisting of carbon and hydrogen, and also include coal and crude oil. Before the processing of raw natural gas, it is composed beforehand of methane and also contains different amounts of ethane, propane, butane, and pentane, commonly known as natural gas liquids. Raw natural gas may also contain non-energy compounds such as nitrogen, carbon dioxide, hydrogen, sulfide, and water. Most NGLs and all non-energy compounds are removed in processing plants before the natural gas is marketable and placed into pipelines. Natural gas from coal, also known as cobalted methane, is also a pure form of natural gas found within underground coal deposits. Natural gas is found in contained pores and fractures of sedimental rock deep beneath the surface of the earth and the ocean floors. The portion of sedimental rock layer, or a formation, that contains natural gas is often referred as a reservoir, field, or pool.
How is natural gas formed?
Natural gas is a fossil fuel formed from millions of years ago from decaying plant and animal matter buried in sedimental rock layers. Heat and pressure transform plants and animals into solid, liquid, or gaseous hydrocarbons.
Natural gas is used for
Natural gas can be used for home heating, water heating, and also to fuel other large appliances such as stoves, washer and dryers, and even barbecues. Natural gas that is brought up from under the ground is millions years old. It has been part of the Canadian industry since it was discovered in New Brunswick in 1859. In 1883, natural gas was discovered in southeast Alberta. Canada's first offshore discovery was found in Nova Scotia in 1967. Today, about one-third of Canada's entire energy needs are met by natural gas. It is abundant, relatively easy to transport through pipelines, and burns more cleanly than any other hydrocarbon. Because of these properties, natural gas has become an important fuel for residential, commercial, and industrial applications.
the recovery.
Gas. Extracting oil and natural gas from a deep underground isn't as easy as drilling or completing a well. It was common to recover as little as 10% of the available oil in a reservoir, leaving the rest underground because the technology just did not exist at the time. Today, advanced technology allows production to about 60% of the available resources from a formation. There are many ways to recover natural gas, such as primary recovery, secondary recovery, enhanced recovery, thermal, gas injection, or even chemical. Primary recovery depends on the underground pressure to drive fluids to the surface. When the pressure falls, artificial lift technologies like pumps are used to bring fluids to the surface. Secondary recovery is the most widely applied enhanced recovery technique. Water that is produced is separated from the oil in the primary recovery, and boosting all oil recovery disposes water waste, putting it all back where it came from. Enhanced recovery techniques include the mobilizing of the remaining oil. These techniques are separated into thermal, which entails injection steam into the formation, gas injection with its miscible or immiscible gases, or chemical flooding, which involves mixing dense water, soluble polymers with water and injecting the mixture into the field.
Storage.
Gas. Natural gas, like most other goods, can be stored for an unlimited period of time. The exploration, production, and transportation of natural gas takes time, and the natural gas that reaches its destination is not always needed right away, so it is then inserted into an underground storage facility. These storage facilities can be found in your local market centers that do not have a ready supply of locally produced natural gas. Most likely, natural gas has been a seasonal fuel. The demand for natural gas is usually higher during the winter, mostly because it is used for heat in residential and commercial environments. Stored natural gas plays an important role in ensuring that any excess supply delivered during the summer months is available to meet the increased demand for winter months. However, with the recent trend towards natural gas-fired electric generation, Demand for natural gas during the summer months is now increased due to the demand for electricity to power air conditioners. Natural gas in storage also serves an insurance against an unforeseen accidents, natural disasters, or other occurrences that may affect the production or delivery of natural gas.
How's the taste?
The efficient and effective movement of natural gas from a producing region to a consumption region require a major and complicated transportation system. In many cases, natural gas produced from a particular well will have to travel a far distance to reach the point where it will be used. The transportation system for natural gas consists of a complex chain of pipelines designed to quickly and efficiently transport natural gas from its origin to the areas of high natural gas demand. Transportation of natural gas is closely linked to its storage. The natural gas being transported will not always be used immediately, so it is then put into storage facilities for when it is needed. There are three major types of pipelines along the transportation route: the gathering system, the interstate system, and the distribution system. The gathering system consists of low-pressure, small-diameter pipelines that transport raw natural gas from the wellhead to the processing plant. Should natural gas from a particular well have high sulfur and carbon dioxide content, a specialized sour gas gathering pipe must be installed. Sour gas is corrosive. Thus, its transportation from the wellhead to the sweetening plant must be done carefully. Pipelines can be characterized as interstate or intrastate. Interstate pipelines can be remembered by comparing it to all interstate highway systems. They carry natural gas across state borders, in some cases clear around the country. Intrastate pipelines, on the other hand, transport natural gas within a particular state. This section will cover only the basics of interstate natural gas pipelines. However, the technical and operational details discussed are essentially the same for intrastate pipelines. Distribution is the final step in delivering natural gas to its customers. Most of the time, large companies and electric generation customers receive natural gas directly from high-capacity interstate and intrastate pipelines. Most other users receive natural gas from their local gas utility, also called a local distribution company, LDC for short. LDCs are regulated utilities involved in the delivery of natural gas to consumers within the specific geographic area. There are two basic types of natural gas utilities: those owned by investors, the public gas system owned by local governments. Local distribution companies typically transport natural gas from delivery points located on interstate and intrastate pipelines to households and businesses through thousands of miles of small diameter distribution pipes. The delivery point where the natural gas is transferred from a transmission pipeline to the local gas utility is often termed the city gate. It is an important market center for the pricing of natural gas in large urban areas. Typically, utilities take ownership to the natural gas at the city gate and deliver it to each individual customer's meter. This requires a very extensive network of small diameter distribution. In the U.S. Department of Transportation's Pipeline and Hazardous Materials Safety Administration reports that there are over 2 million miles of distribution pipes in the U.S., including city mains and service pipelines that connect each meter to the main. Because of this, transportation infrastructure requires to move natural gas to many diverse customers across a reasonable wide geographic area. Distribution costs typically make up about half of the natural gas for households and small volume customers. While large pipelines can reduce unit costs by transmitting large volumes of natural gas, distribution companies must deliver relatively small volumes to make many more different locations. According to the EIA, Energy Information Administration, transmission and distribution costs represented about half of a typical residential natural gas customer's monthly gas utility bill in 2009, with cost of the physical natural gas commodity itself, representing the other half.
How is natural gas proved in the environment?
Although natural gas is an important role for our source of energy and reducing pollution and maintaining a clean and healthy environment, natural gas can be improved in our environment. Natural gas is composed of a methane, and the main products of the combustion of natural gas are carbon dioxide and water vapor, complex molecules with a higher carbon ratio and higher nitrogen sulfate contents. This means that when combusted, coal and oil released higher levels of harmful emissions, including a higher ratio of carbon emissions, nitrogen oxides, and sulfur dioxide. Coal and fuel oil are released ashes particles into the environment. Substances that do not burn are then carried into the atmosphere and contributed to pollution. The combustion of natural gas, on the other hand, releases very small amounts of sulfur dioxide and nitrogen oxides, virtually no ash or no particulate matter. The lower levels of carbon dioxide, carbon monoxide, and other relative hypocarbons, in a nutshell, combustion of natural gas is much more healthy for our environment. But the elements that make up our natural gas are what is harmful to our environment.
Measuring of natural gas.
Natural gas can be measured in many ways, although the most common way to measure natural gas is by the unit of gigajoules, GJ for short, which means 1 billion joules, the metric measure for heat or energy. Other measures are MCF, 1,000 cubic feet, and BTU, British Thermal Unit.
Is it used at other areas?
Gas is not only used in homes for heating and cooling systems, but it can be used in pipeline distribution, industrial companies, commercial companies, but mainly used for electric power.
That's it for today's show of natural gas.